All right, let's do these two problems in activity 2. So pause, work number 1, please. Okay, now work number 1. M and N are midpoints. Okay, so AM equals BM, and DN equals DC. This side, these are definitely, these are not necessarily equal, and that doesn't matter. Calculate the length. Oh yeah, and we're given another clue here. The area of the big rectangle, big trapezoid equals 75. Calculate the length of MN. All right, how are we gonna do this? So if these are midpoints, then the total height has to be what? Double that, so 6 centimeters. So we'll put this in the area formula, and MN will be the average length of, I'll take AD plus BC and divide by 2, right? Because it's the average of those two lengths. All right. So let's go ahead and write what's the formula for the area of the trapezoid? Area of a trapezoid is the base 1 plus base 2 times the height divided by, oops, crud, broke my pencil, divided by 2. We'll use a pen, divided by 2. So that's the area. So it's wanting to find the length of MN. So, like I said, the length of MN is, this is the way I do it anyways, is looking at this AD plus BC divided by 2 is that middle part. Because, okay, here's another little moving around triangles. If I take this little triangle down here and flip it around that midpoint, I'm going to have a square end here, right? I've made it this long, right? And if I take, I've made it, there's my end, point N, and if I take this part down here, it's just a way of looking at it, not really proof, but I sling that around up here, and I put it up here, then now I have a rectangle that is, the base is MN. So MN, this times 6 should equal 75. Does that make sense? I hope and I would get the same way here. And you can see that I was saying if I take away the H there, I was saying the average of AD plus BC divided by 2, that would be MN, right? So I'm saying MN, which is base 1 plus base 2 divided by 2, MN times the height, give me the area. And the height is 6. So I've got MN, the length of MN, times 6 equals 75. So MN equals 75 divided by 6. 72, so it'd be 12.5 centimeters or whatever. So there you go. 6 times 12.5 gives me 75. And that's what that MN has to be. I hope this made sense to you. If I take this little triangle right here and I rotate it about point N, 180 degrees, it fits right up there and it covers in that spot because of parallel lines and good stuff. Okay, and the same with up here. If I take this little triangle here, swing it around, and stick it up there, then I've got MN times the height gives me the area. So you can take any trapezoid, cut it in half, parallel, with the parallel sides, and flip that triangle over, and flip that triangle over, and you've got a rectangle with the same area as the trapezoid that you cut into pieces. Okay. All right, let's look at this one down here now. Once again, like we did in the last one, I think it was number 3 there we were doing, and I was saying, hey, you don't have to find the entire perimeter to get that ratio of perimeters. You have corresponding sides. So here we have two all equilateral triangles are similar to one another, right? 60 degrees, 60 degrees, 60 degrees, 60 degrees, 60 degrees, same shape, different sides. So we either need to find the length of the side of this one and compare it with the 8, right, to get our ratios of perimeters, or we can drop this down and find the altitude of this one and then find the ratio. Okay, I think I'll just do it both ways since I'm a geeky math teacher. So hopefully you did it one of these ways. And if you haven't paused and stopped already, okay, pause it and find the perimeter. And if you really want to find, the perimeter of this, okay, pause. Okay, welcome back. 8 plus 8 plus 8, 24 is the perimeter of this one. And you can go ahead and find, let's see, how would you do this one? This would be 6 divided by the square root of 3 is divided by the square root of 3. So that'd be 6 square root of 3 divided by 3. Is it 2 square root of 3? Let's see if I get this right. 2 squared. Oh man, this is the one they were doing the last time. This over here be 4 square root of 3. So 4 square root of 3, 4 square root of 3, 4 square root of 3. Add those up. That's 12 square root of 3. And then doing the big triangle to the little triangle. So there's one ratio. Let's check if all these ratios. So the ratio of the perimeters, the way I'm getting them, I got 8 plus 8 plus 8, 24 on the bottom. And the top is 12 square root of 3, right? I got 4 square roots of 3, 3 square roots, 4 square roots of 3, and 4 square roots of 3. And did I get that right? Let's see. Let me check real quick. 6 squared plus 2 square root of 3 squared equals 4 square root of 3 squared. All right, we want to check our little right triangle here. Our little special right triangle. You probably have these memorized better than I do because I'm a little rusty on this. So it's 4 times 3, 12 equals 16 times 3, 48. Okay, cool. So that checks out. So we got, I got this ratio, 12 square root of 3. Or I could do the ratio of one of these sides to one of these sides. So that's 4 square root of 3 over 8. Are these the same? Well, let's see here. Oops, are these the same? I would do, yeah, this would wind up being a 2. So I've got, there's our famous old number, square root of 3 over 2. That's the ratio of the perimeters. And sure enough, if I do this 4 and 8, I get square root of 3 over 2. Okay, so that came out the same. And just for fun, I would have, this would be half, this would be 4. So 4 plus 4 square root of 3. Is that right? 4 squared plus 4 square root of 3 squared equals 8 squared. Is that right? 16 plus 16 times 3, 48 equals 64. Check. Okay, so this height is 4 square root of 3. And so the ratios of this to this, so if I did 4 square root of 3 over this height 6. Uh-oh, I've done something wrong. What did I do wrong? Because that doesn't come out the same. These heights should be the same. What did I do wrong? Maybe you see my mistake. I don't know. This is 1. This would be square root of 3, and this would be 2. What did I do wrong? Why is that not an 8? So I'm going from... Wait, I'm supposed to be going from the... Oh, did I go the opposite way? No, I got square root of 3 over 2. In this one, I've got 2 square root of 3 over 3. That's not the same. Well, that's a bummer. Where did I go wrong? I'm using this altitude. There should not be a mistake. This length, these lengths should also be similar lengths. What did I do wrong? Force. Okay. Multiplied by 2. I've done something wrong here. What have I done wrong? Multiplied by 2 there. 4 square root of 3 over 6. Well, shucks, I can't find my mistake. I'm going to go with this one because we added up all these areas. We added up all these lengths of sides. And we got square root of 3 over 2, and I got square root of 3 over 2 using one side. And I don't know where I've messed up here, and I don't want to waste any more of your time with me trying to find my mistake. Maybe you found a mistake already. I don't know. That's a bummer. I didn't go the wrong direction, did I go? I think I've been going the wrong direction. I think I was doing the bigger. That's the bigger triangle. This is the bigger triangle. 4 square root of 3 is bigger than 6. So if I did 6 over 4 square root of 3, multiplied both top and bottom by square root of 3 over 3, square root of 3, I get 6 square root of 3 over 12. Oh, geez. That's what I did wrong. Yeah. So there I get my square root of 3 over 2. So have I been going the wrong direction? Yeah, I did. I'm going, I got the, and I shouldn't have put it up here on the area. Maybe I need another cup of tea. So if you ever get confused on these, don't worry. You're not the only one who gets confused. This is not the areas. This is the perimeter ratio. Ratio of perimeter. Okay, so in the ratio of perimeter, I did it again, and then I did another, and then I made a mistake, and I found out, and I've been going from the, obviously, yes, I'm sorry, square root of 3 is smaller than 2. Square root of 3 is smaller than 2. I've been going the opposite direction. So it's supposed to be the ratio of perimeters. Sorry, this is perimeters equals 2 over the square root of 3. Yeah, so you got to make sure you're going the correct direction, right? They want the ratio of ABC on top and MNP on the bottom, the big one to the little one. And I accidentally, on that last time, I went little to big, and that's why I got that messed up on there. Okay, so then area. So your area ratio is going to be equal to 2 square root of 3 squared equals 4 over 3. So there you go. And that's all there is to it. If you wanted to double check it by getting the areas and do it, well, let's do that real quick. Let's do that just for the heck of it. I'd have 8 times the height. 8, let's do that. 8 times 4 square root of 3 over 4 square root of 3 times 6, the height of this one. So I'd want 4 square root of 3, cross that out, simplify 8 over 6, 4 over 3. So we did a whole bunch of checking here. I hope that wasn't too confusing. And I found I made a mistake in the middle and corrected that mistake. And so there you go. Got to see your math tutor kind of stumbling through it there. and it's a mess, but in the end, there's your answer. I hope that's the answer you got. And if not, just do it again yourself and see what you get. Just remember that a shortcut is if you find the length of any side and comparing it to the length of any of the corresponding side or the altitude in your similar figures, that gives you that ratio of perimeters. Just one side, one corresponding side, the ratio of it to the corresponding side of the other one gives you the ratio of the perimeters. And then you square that, you get the ratio of areas. Hope this is helpful, Kenda, and that is lesson 2. All right, you have any questions? Just let me know.